Ever since it was first discovered, graphene has been hailed as one of the most important breakthroughs in material science since the plastic revolution. But first of all, what is graphene? Well, graphene is a two-dimensional hexagonal lattice made from graphite, which is a three-dimensional crystalline structure composed of tightly bound carbon atoms that are less than 100 nanometers in size. To put this into perspective, a nanometer equals to a billionth of a meter, which is about the size of 10 atoms. You can create this material at home using a pencil and a scotch tape. We all know that the tip of the pencil is not lead, but graphite. When you write, layers of graphite slide off the tip of the pencil and stick to the paper. Usually, many layers are stuck on top of each other, but once in a while, you get a single layer of carbon atoms, which are called graphene. This was first discovered in 2004 by Andrew Game and Konstantin Novoselov. They were able to achieve this by putting a graphite flake onto a tape, folded it, and then cleaved the flake in half. They repeated this procedure several times, and from there, they dissolved the tape with chemicals, and then studied the resulting fragments through a microscope. They found out that the remaining pieces are a single atom thick. It was very unexpected, because everyone thought it would not be chemically stable. But then, everyone was astonished by this discovery, and later, the two scientists were awarded a Nobel Peace Prize in 2010. It may not sound much, but changing the arrangement of atoms from 3D to 2D unlocks incredible physical properties. It is over 100 times stronger than steel, while being incredibly thin at only one atom thick. It's so strong that only two atomic layers of the material can be bulletproof. It's almost completely transparent and extremely light. It might also be the best conductor of electricity and heat known to man. This could be the key to a lot of mind-blowing technology that we could produce. But that was over 15 years ago. All of this sounds amazing, but how come it hasn't taken over the world yet? Why is the market not flooded with all of these graphene-based products? The main problem since then has been how to scale up production of the material, which must be ensured to have a good and consistent quality. Mass producing the material is, at least for now, very complex and expensive. Because these types of products are supposed to be significantly better than what's already available out there. If they're not as good as the material is trying to replace or compete with, then why even bother? An example of this would be silicon. It is an excellent material for use in electronics because of its semiconducting qualities. Many experts in the industry don't see it as having many weaknesses. If it's going to topple the king from its throne with the added cost and struggle to produce it, then it should be worth it.
Generally, it's a product that will make everything better into the future.
Thinnest material in the world, it's the lightest, it's the strongest.
One of the greatest discoveries of the 21st century.
A lot of buses were made, but it never went anywhere. Where are all the graphene wonders that we were promised?
A global race for graphene.
Really is the next wonder material in the world.
The bulletproof armors, ultra-lightweight aircraft, a space elevator?
So the next time man walks on the moon, maybe he'll take the elevator to get there.
Most of these products are the things we typically see in sci-fi movies.
Especially the elevator one. A decade and a half later, nothing. But I'm not saying it's gone. It's just been quiet.
Of course, over these past few years, there have been a lot of major improvements, such as a much matured production method and technology advancements.
Most of the products we have today are somewhat enhanced by graphene.
Scientists and engineers are hard at work to exploit its unique physical properties, to make flexible displays, smaller but smarter yet efficient computing devices, composite materials, better solar panels, and many more.
But even though progress hasn't been as fast as many would have hoped, researchers and product makers are now at last beginning to make some headway. Which brings me to the topic of this presentation, which is about graphene batteries. As I've said earlier, graphene is one of the, if not the best, conductor humankind has discovered. But let me add a little bit more to that.
You see, the fundamental properties of this material can make it very promising for a multitude of applications. In particular, it has attracted great interest in energy storage. Currently, graphene is the most studied material for charge storage, and the results from many laboratories confirm its potential to change today's energy storage landscape. Specifically, Graphene could present several new features for energy storage devices, such as smaller capacitors, completely flexible and even rollable energy storage devices, transparent batteries, longer life cycles, higher capacity, and faster charging rates. I would like to highlight this portion of the video with a particular product known as the G-Series, which is a lithium-ion based power bank enhanced with graphene, made by a company based in the US called Real Graphene, which made it onto the headlines but then quickly gone down. The company that made this product shows a lot of promise, and could be one of the best ways to introduce the material to the market. They were able to make this product by combining it in a composite form inside the electrodes of a battery. You can change its characteristics to give you much better performance than the typical ones you see in your smartphone and or laptops. Digital Trends spoke with the CEO, Samuel Gong, about the technology and gives insights of what their product is like. With an average phone battery of about 3000 mAh, you're looking at around 1.5 hours to get from 0 to 100%. For these graphene-enhanced batteries, it's just about 20 minutes. To achieve this, you need to use a 60-watt charging brick. So if you pump 60 watts into a regular battery, it would fry itself. The graphene batteries also have a longer lifetime. Most phone batteries can last around 600 charge cycles. These new batteries are rated for 1500 cycles for the same capacity. To top it all off, it's safer than regular batteries because the cell generates much less heat and runs much cooler.
As Gong states, quote, "We'll be seeing graphene batteries in actual big brand devices within a year. Not in every single device, but trickling down from the higher end first. People think graphene is a thing of the future, but I'm here to correct them. It's here, now. We create a battery that can charge super fast, is very cool, and has a long lifetime in terms of..."
With all of these amazing benefits, it should at least have some downsides, right? Well, the only thing that I could think of is the added cost of a battery component of a phone, if it somehow became the standard in the near future. But I think consumers wouldn't mind. You see, this is just the beginning. Right now, there are still a lot of challenges that are needed to be addressed and overcome. We need more studies to bring out the true potential of graphene before it can reliably be used in various technologies. Although the number of graphene-based patent applications exploded since 2010, it's still a sixth of all silicon-related applications, which demonstrates why this transition will take time. On the other hand, considering that graphene consists of carbon, it is much more abundant in nature, which means it's a much more suitable technology for mass production. All in all, we should keep our eyes on these advancements and look forward to a much brighter future of our technologies. Peace. Bago ako pa makalimutan, teka, salamin ko. Lang. Okay na to? Yeah. Shoutout sa mga... Teka. Shoutout sa mga ka-rival ko na sina Christian Gaete at James Edward. Umanda kayo sa akin yari yun. Tapos, ayaw nga pala si Victoria Cruz. May big ice cream ko. Hindi ko makakalimutan yan. Tapos, sa mga tropa ko at mga klase ko sa 2RT and Tim Jenkins. And of course, kay Sir Lustre. Kay Santo Lustre ng Don Bosco Technical College. Thank you, sir. Bawal magingay. Talag ng mga taas-taas. Lang. Bye.